available for later.
Hello, everyone. My name is Artis Harold, and I'm on the NESTA board. Elaine Bowles-Graham recently introduced herself. If you missed Elaine, she is also on the NESTA board, and we are the facilitators for today's Mars workshop. I'd like to take a minute and introduce our first presenter and primary presenter, Jackie Kane. Jackie is a colleague who taught high school science in the Toledo area, Toledo, Ohio. And she primarily taught 7th through 12th grade, recently retired. And she developed a real appreciation of exploring Mars using a professional tool that's free and available for you to use on just a website. And Jackie's going to talk to us about it. First of all, I'll turn it over to Jackie and let her introduce her co-presenter.
Progress.
Okay to share over you, Elaine.
Yep, we're off to share.
Thank you, Artis and Elaine. When I study the Earth, I want to unravel its story. So now with JMARS, I can unravel the story of Mars and then apply it to my study of the Earth. So that's pretty exciting for me.
What?
What were your thoughts about dinner?
Oh, I thought you were going to get your own.
My goal today is to make all this material valuable to you all within an hour and also give you practice so you feel confident using it. So you've already met Artis, and Elaine is there in the background, making sure everything works. Scott Dickenscheid is our guest from JMARS. He's a senior scientific software engineer. And Scott, if you would unmute yourself and talk a little bit about what you do with JMARS and what JMARS is.
Sure. So yeah, as Jackie said, I'm Scott Dickenscheid. I work at Arizona State University in Tempe, Arizona. I'm one of the developers on the JMARS project. I've actually been on the team for 15 years, and the project existed before I joined. So JMARS has actually been a publicly available tool for 18 years now. It was originally written and it's still maintained as a mission planning tool for the NASA Themis instrument, which is orbiting Mars and has been orbiting Mars since 2001. So it's used actively to plan for that mission. It's also used to do some planning for the EMIRS mission, which arrived at Mars earlier this year. We also are used for analysis for the HiRISE instrument at the University of Arizona and a lot of other instruments around Mars. We also do a similar version of this tool called J-Asteroid, which was involved with the OSIRIS-REx mission. We're actually involved with the Lucy mission, which is launching next month. We're going to be involved with the Europa Clipper mission. So this application, even though its origins are with Mars and it's actively supporting Mars development, it's much bigger than just Mars. If you like it for Mars, you can expand to other planetary bodies. But it's been around for a long time. We've got a team of about 10 full-time people that are working on JMARS right now. And even though we actively support NASA missions, we're also very motivated to support teachers bringing school kids and adults into exploring the data that's been collected as well. So we're here to support you and here to support Jackie in her efforts to make this all more accessible to you and to your students. So. hopefully you find it to be a useful tool.
Okay, thank you very much, Scott. And I'll continue here. Our format today is just going to be to introduce JMARS and the Directions website, give you some practice, and then have a Q&A at the end. I will be monitoring the chat box, so if you do have questions, I will periodically look at that, and also Artis and Elaine will let me know if you're having any problems as we go through this. So at first I need to address 3 questions I imagine you all have. Why Mars, why JMARS, and why my website? Mars is not specifically mentioned in the standards, but it is a great platform to address the standards for several reasons. First, by unraveling the story of Mars, we can understand more about Earth's past, how Earth changes, maybe how Earth will react to climate change, and more even perhaps about the beginning of life. So Mars in many ways is a simplified model of the Earth. Mars does not have a dense atmosphere, radiation shielding, plate tectonics, or vegetation that the Earth has. But this creates a really unique opportunity to apply the same universal principles and laws to Mars that we applied on Earth, except the results are a little bit different because the variables are different, as I mentioned before. So students can learn about these differences and how they are critical in understanding Mars, and then how they might be reacting with Earth. But it gives them a great sense of applying what they already know to a little bit of a new situation. In addition to this, unlike Earth, the evidence for what has happened on Mars has been there since the existence of Mars about 4.5 billion years ago. Secondly, putting a person on Mars may be within reach for the first time. Students are hearing and will be hearing about Mars in their lifetime. And educationally, you can meet the NGSS standards, especially the 2nd and 3rd dimensions, dealing with science principles and concepts. And I will address some of these, and also in the teachers section of my website, there's quite a bit there. Secondly, why JMARS? Mars lends itself to wonderment and to open-ended exploration. As a teacher, you can simply build off what students already know, have them ask questions, and then help them develop their own questioning skills. While exploring Mars with JMARS images, students can form the questions, and the questions are not easy to Google. So unlike a lot of worksheets and that are given by teachers, a lot of the answers can be found on the internet, but questions like, well, what is that is not easily to answer on the internet. JMARS also has, as Scott mentioned, about 30 other planetary objects. And in a few minutes, you'll be able to explore Europa or some of the other moons, or our moon or Mercury, and look at perhaps the differences between craters on those planetary objects. In 2024, NASA plans to send a spacecraft to one of near Jupiter's icy moon called Europa. And even with JMARS, you can access many of the same images that cause the scientists to wonder if there's life in the liquid water below Europa's ice. So it's a very powerful tool, and the students can use it. JMARS is the site that these planetary scientists use. Introducing JMARS to the students is giving them the same tool that the same images that the planetary scientists use. JMARS is not a source of information like a textbook or a website. I look at JMARS as an exploration tool. You can use JMARS for short demonstrations, classroom activities, or even longer research projects. Maybe your students will be making new science discoveries themselves, as some 7th grade science students did using JMARS. Why my website? First, I want to acknowledge that the great tutorials on the JMARS website and the educational guide to Mars research listed there. However, since it's very hard to keep tutorials and manuals updated, I needed an updatable cheat sheet for myself with directions if I forgot how to do something or I missed a critical how to update. So that's why I built my website. I also wanted to explore Mars without mastering new technology or going through lengthy tutorials. Therefore, the results was a direction site rather than an educational tutorial or filled with lots of material. However, there is quite a bit of material on the teacher section. So I thought others like you might like this resources, and so Artis has given me this opportunity to share with you. So if you, hopefully you've downloaded JMARS and looked at and bookmarked my website. So you will need to have JMARS open after this. So if you open JMARS as I finish talking here, that will help you with learning how to use it. Those of you that have gone to my website, it's composed of 3 tabs. The first tab is the home page with some other information like your teacher resource page. The second tab gives you a little background about Mars if you work with students who know that it's a planet, but not much more. And then an overview of Mars to help you learn how to use it, which I will go over briefly here, so you don't need to do that, but it's there for you or your students as you have need. But hopefully you'll be using the third tab mostly, which is a set of simple directions, basic directions for getting to into using some of the tools in JMARS. So let's take a short view of Mars. This is what Mars looks like when you zoom in on it. From the sky at night, it looks like a little red dot in the sky. So if you could give me hands up if you think you have students who knows why Mars is this brown or reddish color. And I'll take a moment here to see if there's any hands up. Artist or Elaine, did you see any hands up here?
A couple. Yeah, Brandon,
few.
they're up. Yep.
Okay,
See quite
that's
a few.
good. Well, that's great. So one way scientists look at Mars is by elevation. And so they often color it with like this, where blue is very low level and the brown and the white are the high points in Mars. There is no sea level because there's no sea on Mars, at least not now. And so it's very difficult to figure out what is zero elevation. They came up with a solution for that. So the blue is negative numbers and the white here is high numbers. Another way to look at Mars is to take a look at the dust on Mars. And so you can simply go to the dust index map and up will come a map of different places where there's dust. Here, the red represents a lot of dust. And this is important because it's very hard to see beneath the dust to look at the surface composition. So a lot of our mineral studies are in areas where it's not as dusty. Another way to look at Mars is a different layer called the thermal inertia layer. Inertia, of course, means resistance to change, and thermal is your heat energy. So in this case, the purple doesn't have much thermal energy. One thing you can do with your students is go back to the dust and the elevation maps and see if there's any patterns that they can detect. So let's go over to our JMARS tool, and let me introduce it to you if you haven't had a chance to look at it. This is what you get when you open up JMARS. Mostly I have an investigation layer here that you probably don't have open yet. This middle section is called the main view. And on the left is all your information built in layers, where the top layer, called in this case, the Explore on Mars layer, will be what is shown in your view here. Along the top, you have a typical menu of help and tools and places in view. Below that, you have another menu. The first thing you notice here in this gray section is the magnifying glass. So you can click that and search Olympus Mons or any other feature that you know of, or you can simply put in a longitude and latitude value and it will automatically center on that. To the right of that, you have a cursor, a hand, a profile button tool, a ruler, which is measuring distances, and the I button, which is very helpful because once you click that, it will, and bring your cursor onto the map, it'll give you all the data that they have underneath that, that spot in that layer. Down at the bottom, over in the left-hand corner, You see two valuable things here. One is an overlay a section. You can toggle that up and it'll give you map overlays such as longitude and latitude and names and the north arrow and the scale. Below that is a quick access. So if you wanted to look at a 3D model or a profile, you can get to that quickly and you'll have a chance to work on that. At this point, I'm going to switch screens. This is it. So here's the PowerPoint, and this one will be some directions to go through with your JMARS. So if anybody is having trouble opening up their JMARS, you should put it in the chat section. Otherwise, I'm going to continue helping you learn how to use JMARS. So there's 5 steps here. First, in the JMARS search box, which is up here, we're going to highlight the 00 and we're going to put in a 7, comma, space, 288. You do not need to put down the degrees or the directions. If you have a negative, a south latitude, you can use a negative number. If you want to locate somewhere with a west longitude degree, you can put a W here and it'll automatically change it to the east because this is default east. So if we click enter there, we come up with a zoomed in image of that spot centered. And what I want to do is zoom out a little bit. So in the upper right hand corner with zoom, let's click on 4 pixels per degree. And you can see a very cluttered map that we need to clear up. So going down into overlays in the lower left hand corner, clicking on overlays, and you can, down at the bottom is the nomenclature layer, and you can turn that off by clicking on the M or by sliding the opacity button down. We're going to leave that off for now. If you want to find out other labeled parts to Mars, you can double click on nomenclature and choose craters or volcanoes or valleys to just bring those up rather than the craters. Now I'd like you to explore a little bit what happens when you take each of these layers off. So in your, and let me stop here for a minute. Artists, is anybody having trouble that they've said?
I have not
On
seen
chat.
anything in the chat, no.
Okay, great. So if you take this slider and turn off the explore map, underneath it is the color map, an average, a more natural view of it. If you take that off, you get a colorized elevation, which is similar to the Explorer map, as you can see. But this one is digitized. So if you turn on the I button and turn off the intro screen there, anywhere I put the cursor, you can get the data at that location. This in this example is elevation, nighttime temperature, and thermal inertia. For example, if you go to the top of Olympus Mons, it says it's 21,000 meters high. And if you go down to the bottom of that, you down to minus 3,700 something meters deep. So that's quite a difference in elevation there. If we take off the colorized, let's get rid of the overlay. If you take off the colorized elevation, you get daytime temperature, which doesn't look like much here. Let's get rid of the eye and go back to the cursor. Pardon?
There is one question. So should we be able to see your JMARS screen?
Yes.
Because right now you're sharing the instructions.
Okay, thank you very much. I'm going to stop. I'm going to share a new slide here and slide desktop 1. That didn't work. Sorry.
Right now, we can see the instruction screen as well as the JMARS screen,
Okay, great. So,
side by side.
okay, super. So do I need to go back at all to anybody?
Yeah, they've asked to go back a little bit, please.
Okay, so let's go back to the beginning. If we go back here to starting over, sorry about that. Sorry.
Jackie, is there a way we could see just that screen? Because it's kind of tiny, instead of looking at the directions also?
Is that better?
It's bigger, yes.
Okay. So in this screen, we want to go to a different site. So let's type in the upper right-hand corner here instead of 00, let's put 7,288. You need to have a space in there, sorry. 7, space 288, push enter, and it will zoom into that space according to the zoom generic value there, which is 32.
Jackie, we have a question about how did you get to this screen that we're looking at?
It started probably with 00. Oops. 0,0. Oops. This is how it should have opened. Is that correct? If whoever had the question wants to unmute themselves. Does this answer the question?
Hi, can you hear me?
Yes,
Yeah.
I can.
You can, good, okay. So I'm looking at the JMARS interface. Should I click on the layer manager tab? I'm not sure if I'm in the right place.
Did you download JMARS?
I think so. I got a password and username. They
Great,
sent
and
me-
then did you open it up?
I went to my email and then responded and changed my login password. I think that what I am looking at is JMARS, but I don't know for sure.
You should have had in your downloads a little circle with a big J on it.
In my downloads.
Well, maybe in your applications.
Okay, well then, why don't we assume that I'm going to get there? And my question to you is that an opening screen? Is that a home screen? Where do I get to that? How do I get-
Yes. What if you open it up and you've signed in? This is what will come up.
Okay, let me keep playing here then. Let's assume that the mistake's on my end.
Okay.
I'll
Get
go
back
ahead
to us if. Scott, are you still on? Okay.
Yeah, I'm still here.
So if he has more trouble, I'm not quite sure how to tell him to get to this stage. He downloaded and he registered. So how does he get to this screen?
Yeah, when you run the application, it should pop up and ask you to enter your user ID and password or log in as guest. And if
Okay.
you put your information in that screen, and then this should be the next screen that comes up.
Okay, thank you.
Sure.
I'm going to unmute. Thanks a lot.
Okay, thank you. Okay, so here, if we follow these 5 directions, we can put in a 7, space 288, push enter, and we get this value. Let's change the zoom in the upper right-hand corner to 4, and we get a larger view of Mars. Now let's go through and take off some of these values. Taking the opacity button and moving that to the left, you can say you get, that's a colored map. You take that off, you get a colorization map, which has, is all numeric. So if you turn on in the upper right-hand corner, the I button, and turn off the information, you can see you have lots of data on every point on your map. So that's very helpful if you want to find specific information, for example, how tall it is on top of Olympus Mons and how far downhill it is. So going back to the cursor button, let's change the zoom, or let's continue on taking the colorized elevation off. You have a daytime image, which doesn't look very pretty. So let's zoom in, say, to 512. And here you have a pretty picture of a crater with some ejecti that looks like a splatter mud pile. You also have a ripple here that seems like it's continued to the crater, and that's kind of interesting to discover. You have a lot of little craters which you can zoom in on. You have some other features here. If you take off the daytime temperature and look at the nighttime, you can see that the rim of the crater and the crater maintains more heat than the other, or at least it reveals more heat than the other. So that might indicate something about the surface. Let's take a look at the distance and profile tool. So up on the top, if you click on the ruler and you go over to measure, let's go back to the explore layer on the top there. So we can click and drag. And in the lower right-hand corner, it'll tell you our distance. Maybe you want to have your students look at the size of the crater compared to the ejecti pattern and seeing if there's any, ratio there that might go along with anything else that any other craters. Another tool that's important is the profile tool, and that's in the upper up on this menu at the top. If you click on the profile, you get a white directions here to click, and we're going to take a little bit off the crater here and draw across the crater and double click to cause the line to change. Then down at the bottom here under view chart, we can click on the profile again, and up comes a profile of that. And you can see that there's a little bit of a hole in the bottom of it. And wherever you slide your pencil here across the crater, you get a profile location. I like to use a profile that has more points to it. So in this blue area in the profile options section under numeric map source, if you click on that and go down to the third one to version 200 meter version 2 and say okay, you can see that the change that happens. So you get a lot more data points to work with there. There's another radial profile that's fantastic to use also, and I have directions on the website for that. The last one I wanted to show you today is the 3D layer. If you go to the Explore Mars layer and click on the 3D button, it turns white. That enables the 3D program to open. Down at the bottom under quick access, if you click on the cube, excuse me, you see a pop-up, and you can toggle that in any direction you want. Doesn't show much variation in elevation, so let's change the elevation exaggeration. To do that, you go down to the bottom again under quick access and click on the mask. Up comes an option, and down at the bottom, you can have, there's a vertical exaggeration. Let's change that to say 40 just for fun, and it'll automatically exaggerate that by 2, so it's really going to be 80. And again, you can toggle this around and have fun looking at different parts of Mars. You can make that bigger and have fun looking around. You can
But
also,
sorry, exaggerating the vertical is very cool. It really shows a lot more detail.
yes, isn't that cool? And it's an easy way to find differences for kids if they have a visual, a way to spin things around. You can also, let me go back one more thing on this one. If you click down here, if you do the sphere, you get a different pop-up. And on this, you can spin the Mars around. So you can look at the deepest spot on Mars, which is right about here. And it's almost opposite this bulge here on Mars, where you have your tallest volcanoes in the solar system, opposite this deep impact basin. Maybe there is a correlation between the two, and scientists are hypothesizing about that. Using these directions on temperature charts, which are on my website, you can find a calculated temperature for the day on that spot and for the year. And if you follow those directions, you get something like this. I think I can make this bigger. Oops. Where I took 2 spots on top of Mount Olympus Mons and a place near the bottom, and you can see the red is Olympus Mons. It's colder than at the bottom. Oops, sorry. And if you click on year, you can see that the top of Olympus Mons is colder. One interesting attribute here for those who like chemistry is that it doesn't seem to get colder than a particular spot here. And that has to do with the deposition of CO2 as frost on the ground, releasing heat, and it tends not to let the ground get any colder than a particular amount. You can also add a day and night temperature over day. And in the case of our crater, you can get spots that have less, in this case, probably less dust, so that they show that they're giving off more heat at night. I would love to have the time to do a 3-week research project for my students. This was a program, MSIP, that was available in the last couple decades. And I think tens of thousands of students went through this. Some of them got their work published. It's still there, you can use it. But you can also do independent research. And there's also many other places where students can publish the research. So if you're research minded, you can do that. If you don't have 3 weeks on your curriculum to look at a research guide, you can simply have kids look at Mars, Google it, not Google it, but zoom in, look at the different tools and come up with just millions of questions. If they can come up with millions of questions, then you as a teacher can help them design, refine those questions so that there's questions the student, a scientist, or they could answer better than why something happens. So that's where you as a teacher would access those other dimensions in science rather than just learning about Mars. So the goal here is not to learn about Mars as it is to learn about how science is done and how cool Mars really is. Before I let you play around a little bit, I'd like to show you 3 activities I made. These really haven't been done in the classroom much, but you can, they're available here as a file in this program. It's also on the Google Drive, which I sent to you. The trick is the kids have to choose any 3 in a row and find examples of those and then document why they think that's ice or why that's a volcano and not a crater. There's a website here that has a lot of examples that they can use if they get stuck. That's pretty easy. The second one is looking back at the quiz you took, but this time when they take it, they have to make a first guess. Then they have to explore it with the tools and then come back and make a second guess, and then document and validate their reasons for their choice. And the last one is even harder, but it gets at understanding how Mars' story, so that they look at a site like we've been looking at here, and being able to say what happened first, what might have, and describe in the surface here. The only caveat is that they can't say anything they can't back up with science based on the tools they can use for JMARS. So I'm going to give you a little bit over time here, but maybe 10 minutes to browse. Please use this opportunity to go through the JMARS, because if you don't do it now, it might go on the back burner and you might not get back to this. So practice using these tools now. Go to my website with all the directions, or go to the Google Drive where this is as a PDF, and you can scroll through these exercises. And I'm going to take a few minutes to look at the questions on the chat. Do you have anything to say at this moment, Artis?
Yeah, I just wanted to mention, and I'm not sure, Jackie, that you said that earlier, that this tool can be used on like over 30 planetary surfaces. So if Mars isn't your deal and you want to do the moon or Mercury or asteroids, all those data are available as well. And you can do comparative things like compare volcanoes on different planetary bodies and see what you can come up with that way. So it's not just Mars that you can use this tool with. Once you know how to do it, there's a lot of other planetary bodies that you could explore. And it might be something you want to do right now with your short time.
Yeah, that's exciting. I've had people that came here for the first time and looking at this, I said, well, what have you been doing for 10 minutes? And they said, oh, well, I was on Europa and looking at this or that, or I was on Dione or the moon or Mercury. So you can use any of these directions to, in fact, one of my students went to the 3D print device and actually made me a 3D printed object of a Jezero crater where Perseverance landed.
Okay, so Pat, I answered the question about that. I originally put down options without thinking, but it's under the body drop down that's on the main menu for JMARS. File view places body. So if you click on body, that's going to give you the drop down for it.
You see this? Let's just have fun and go to Mercury. I'm still on.
Jackie, do you want to open up for questions here at this point in time while we're kind of exploring?
Yes.
So
Yes,
if anybody wishes,
think-
I was going to say, if anybody wishes to unmute and ask a question, please go ahead and do so, or you can put it into the chat, because we're all exploring this. I'm just sitting here thinking as a teacher, man, I got some great places to send my kids to. when we start doing the solar system and really looking and exploring some data. And so I thank you for showing this and sharing it with us.
Great. I'd love to hear some other people's reaction to this. My goal was to make this useful and exciting and a tool for you. If it's not, and I need to tweak it a little bit, please send me an email. My direction site here down at the bottom has my contact email, which is using RS because I'm into remote sensing. So that's why I made that email list. Is there anybody that would like to share what they've been looking at?
I'll just say that when I used it before, I had some really general questions that could work with lots of different students, like show evidence for water on Mars, water erosion. Another thing you can do is you can just say, you're in charge of a new Mars landing mission, and select your landing site and then explain why it is you picked that site.
Yes, and great. And I think what happens is that once they start asking questions, they want to find the answer themselves. You don't have to tell them to go research it. They will Google it. And for example, when you asked about evidence of water, yes, there's evidence of water there, or at least it looks like it. But for example, is this a stream here? Well, does that mean there was a lot of water there, or where did all that water come from? There was such low air pressure, however, though, that it couldn't really stay as water for very long. So there's a lot of, they know that there's evidence of water there. There's a lot of water frozen underneath it. But was this melt from a glacier? Or was this a running water from some source? There's just so many questions yet that we don't know. And the students that are looking at this is an open-ended field. We don't know the answers yet. And so if they want to do some real research or just find answers for themselves or just get lost and I have just a million questions. Why are there lines here? Well, why is the top of Mars all blue, i.e. low, and not many craters? And then this area here, which is called the lowlands, older area, or highlands, the upper highlands here.
Okay, Jackie, there's a question in the chat from Holly about she's interested in Ceres and Vesta, but I don't see some of the layers I would be interested in. Is there some way to create layers or transfer layers over?
I think so. I haven't explored the other moons lately, but if you look at my screen here under this word layers, at least for Mars, you can click that. And these are all the ones available here. You can also go under browse, or you can search something like, if I wanted to do the temperature layer, or crater counting layer, I could go crater counting. And it has a crater counting thing where I can draw circles and label craters and compare sizes of craters. You'll be able to do this in each one of the layers, although some layers don't have as many layers. Some planetary objects don't have as many layers as the Mars does that I found. You can also do browse and type in, say, an instrument. And if you want to do something like crimson, which are the minerals, you can do crimson SAMs, and this is way too big. You'd have to reduce this. I can't quite do it now. But there's just lots of different layers. I'm not sure what they have for Ceres.
I was looking at the layers that it showed when I clicked on the little plus sign, which gives us the layers. And I found framing, counter crating, nomenclature, 3D, crater database, Da Vinci, custom stamps, custom map, and advanced map. So I found several other layers, but not all of the ones like you have with Mars, because I'm guessing the data that's we've gotten from Mars gives us different layers. So
Yeah, they've done a lot more work with
research.
Mars than they have with the other ones, but it's exciting because we're sending new spacecraft around the other moons, and we're going to come out with more information like this. But right now, if you look at Europa, you know, the students have almost as much information as the scientists have as far as what to work with.
And Rosemary is asking, how do you see the values on the lat long grid? And I'm personally seeing it in the bottom corner there. Whenever we're dragging
Yes,
over
wherever you
them.
put, yeah, wherever you put your, it doesn't have a nice little scale at the edge like most of your maps in the history book, the geography books have. But wherever you put your cursor, it'll tell you the latitude and longitude.
And it's down
You
in
can
that,
also,
it's down in
yeah,
that
it's
lower
down
left
here.
corner.
You can see
Does that
it,
answer your
moving.
question, Rosemary?
Yes, that's fine. Thanks.
Uh-huh.
You can also, under the overlays, change the lat and long. So you can say spacing is 30 and refresh, and it'll change the number of lines you get on your map.
Could I ask a follow-up question? If you wanted it to be centered on the equator and the meridian, can you do that?
Yes. Yes, in the upper right-hand corner, we're next to the magnifying glass. If you highlight that and type in 0, space 0 and hit enter, right in the center here will be pretty much 0, 0. You can also right click in this space and it says resize the entire surface. So you can start it from 0 to 360, or you can put the 0, 0 in the center. You can also resize this depending upon the size of your screen. If you're working with a smaller screen, you can go to 2 ppd. Most of us are at about a 4 ppd. If you have a very large screen, you can go to one that's super large. Please unmute yourself if you have
Oh, I'm
questions or
sorry.
want to share something, that'd be great. Yes, go ahead. Let's see, the quiz.
Did you?
Did we not? Oh, that was,
No, we haven't
did
done
we
it
not do
yet.
the quiz?
We haven't done it yet.
No.
You didn't, you were getting all the information in and out. Would you like to try to do, what would you like for me to put it up?
Oh, yes. Yeah, that'd be great. Let's end with that. That'll be fun.
Okay, I'm gonna take over the screen sharing for a second here.
Thank you.
Uh-huh.
And while she's doing that, before you leave, if you would, you know, make sure that you email me if you have questions, so I can perfect my site.
So for everybody's enjoyment, we have a quick little quiz based on your experience that you've been kind of trying doing, but experience with Earth maps, and try to identify whether this is a valley or a ridge. And you can pop your little answer into the chat if you'd like to, and let me know if this is if you think this is a valley or if this is a ridge. A for ridge, B for valley. If you feel like working with this.
I'm not getting too much response. Are you
No, I think
seeing any response?
I think they're really interested in the other part.
Answer?
V.
It is B. How is this a crater or a volcano?
Someone said it was a volcano. That's good.
Yeah.
Next.
The answer would be a volcano. Which is older, A or B? Correct. B is older. Is this surface dusty or rocky inside this crater? hopefully should be dusty, right? If I'm correct. I could be wrong. It's dusty,
No,
rocky,
it's rocky.
rocky.
And you don't know this from looking at it, but you could do this if you did some of the other tools. So you could take your guess, and then what the students would do is take a guess, and then they correct your guess, and they would
Okay.
get some data to back that up. The night over day would show you that it's rocky in there.
Okay, is this area in the red rectangle steeper in the north-south or the east-west directions? North-south or east-west? Steeper which direction? Yeah, definitely. It's steeper north and south. Very good. How about which is wider, A or B? A is right up here, B is down here. Which would be wider, A or B?
So Matthew, what is your background?
I teach physics and astronomy, but
And you know about map distortion?
that was my guess, is that it was a map projection effect, and that's down towards the South Pole or closer to the South Pole at the bottom.
Yes. And the interesting thing about JMARS is that if you measure that, it will give you the true dimension. So you can go with your students and measure, have them use a ruler and measure it, and it will actually be smaller than the A value.
Thank you for taking part in that, but that could be an example. I could almost see that as being something we could put on Kahoot. We use Kahoot, but for some things, but that could be a way that this could be something that could be put on Kahoot and used as a way for the kids to give response back. For high school or middle, I could be using Kahoot.
Yeah. So Matthew Henderson, what did you think about this?
I liked it. This is my first time teaching. Part of one of the classes I'm teaching this semester has some planetary science in it. I don't have a background in geology, so finding out what tools are available and what data we can get at is really helpful.
Just in case, I was going to say, there's the link to the Google Doc that I utilized Jackie's pictures and did a snippet thing to create the PowerPoint, but there's the presentation if you want to steal it and I guess use it for other things, if that's okay, Jackie.
Oh, absolutely, anything. And it's also in the Google Doc as an activity, as I showed on one of my second activities, so they can copy and paste that. They're put in as Word docs, so feel free to change them any way they want. If they can't find ice, you can always make the tic-tac-toe and put some other word in there. So I see Rosemary up here. Hi, Rosemary. You want to unmute yourself?
Hi there.
Hi, how are you doing?
Good.
You have a beautiful background there with the universe.
Thank you.
You ought to join Artis's special astronomy program she's got going on. Contact her because that's really awesome. But what did you think of JMARS? Ever been there before?
I have seen it a couple of times, been introduced to it, never really played around with it. And I had kind of an immediate interest today, and you answer those questions, and that because I want to export some of the layers in a various format with latitude and longitude starting in a specific place to go into a planetarium program. So this is going to be really helpful for that. And then I can also use it. I teach an astronomy class, introductory astronomy, sort of a 101 class. So that'll be useful.
Great.
So it was great.
Thank you.
Rosemary, I was looking back through the chat and I saw where you had asked, can you use a more limited version just through a browser? And then under layers on the left, I see investigate layers. That was on yours, Jackie. I had the investigate layers, but I don't see that on mine, on my version. of JMARS? That's what a question that Rosemary had put earlier in the chat. That
Wait a minute, the layers?
yeah,
on your-
I saw, yeah, and I saw it too, that you have a layer that says investigate layer.
Oh, I'm sorry. That just pops up whenever you use the I. Let me share
Okay.
again. Okay. All right. Well, whenever you use the I, it loads an investigator layer. And you can always get rid of that when you're done. If it's
what
down
was
here, I
the
can just,
I again? Can you share your screen?
yes, share my screen where I'm at too.
Oh, it's up in the top bar, the navigation bar that has like the search, the hand, the profile,
Oh, okay. I see
zoom
it.
in, zoom out, measure, and there's the eye. Yeah.
Okay, great. Thanks.
Some other people, before we have about 4 minutes left, is there some other people that would like to share what they found or what they were thinking about doing? Because you are your best resource, because you're all teachers, and any ideas you have about how you can implement this into an existing curriculum. I know it's very hard to fill in curriculum on top of what you're already required to do. So if you want to unmute yourself and just add a little bit, that would be great.
I haven't explored the website, but I'm wondering if there on the website or somewhere else there is a list of suggested science questions that students could explore. I'm kind of
Yes.
thinking that teachers and students especially might be overwhelmed by the possibilities.
Okay, let me share my screen again. And on my website here, down at the bottom under teachers, you have the standards and then some lessons. So these are some lessons that I found that I think are really great, that you can adapt if you want, or you can simply just have the kids explore map like they would Google Earth, and then ask questions and say, hey, let me do a profile of that, or let me measure how big that is, and look at the different layers. I think they would have fun just looking around at these materials, but I might be wrong. What do you think about that?
That'll give me something to look at. Like one of the questions that kind of came to mind to me was asking, like, having the students explore the data, notice that there are some places that have more craters than others, and propose some theories about why that might be, and then give them some avenues for investigating their theories to try to support it with some evidence. I think that would be, one example. So if there were some things like that, I'd love to be able to pass it on to teachers.
That's great ideas. And thank you for bringing that up. If you go to type in JMARS on Google, up will come the JMARS website. And if you go under the second tab from the left, you get into a program for high school students, which is the well-vetted, highly structured, teacher-focused, walking kids through, starting from very simple things to more complex things where they end up getting a question. But they'll just say, they'll say, these are the three shapes of craters. You have young ones and have old ones. Some of them have, dips in them. Some of them have peaks in them. Some of them have ejectiles. Some of them, all these things. So you can start just with that website, which is can start at a very simple level and then build up from there. It also has two different sections, one for middle school students and one for high school students.
Jackie, we have one question from Raymond, and he said, can you explore or locate features by name?
Yes. If you go up to the magnifying glass and click on it, let me share my screen again here. this magnifying glass. If you click on that, you can type in Olympus Mons. And it comes up, and then it'll just identify it for you.
Okay, it is 5:01 on my time, and many other of you have different times, but our time has come to an end. I'd like to thank Jackie and Scott for being with us today. And as always, Jackie, you've shared your email somewhere, I think, or your website at least. So
I put Jackie's email in the chat earlier. I'm getting ready to put it in again.
excellent.
And I do have the website down there for JMARS and for Jackie's website.
Thank you. And so if you have any further questions, I'm sure Jackie would be happy to help you, as well as the fact that we will send an email out to all of you in a few days when we have this recording posted on the Nesta website, and then you can go back and access it. So thanks everybody for coming. I hope you enjoyed this. And if you have any other information, please send it along to us.
And Artist, I'd like to also express my thanks for this wonderful opportunity for me to share this, and I hope people use it. And answering your question again about my contact and the contact for JMARS, it's in the footer of my website.
And the other thing that I will also be up probably with the video will be the chat. I will annotate the chat and have that put up too, where links are live through there too. So
Great, thank you.
any other questions? You can hang out and visit with us. We'll turn off the recording if you